This section introduces the project that focuses on building production error alerts for a Next.js micro SaaS. It describes the integration of Sentry for real-time error monitoring, along with a working demo used for testing prior to deployment on post-to-video. The motivation arises from a user experiencing onboarding issues due to production errors. Although the error was logged, no alert was supposed to notify the developer, demonstrating a lack of real-time error awareness in the current setup. The objective is to create a simple, efficient alerting system tailored for a Next.js micro SaaS. Key takeaways include Sentry's capability to capture errors both implicitly, unhandled exceptions, and explicitly, handled errors using SDK methods. The system provides real-time email notifications for new production errors, and the free tier is generally sufficient for micro SaaS applications. Installation begins with adding Sentry's Next.js dependency using pnpm. The next step involves running an initialization wizard via the command line, where prompts guide the user through setting up their Sentry project. This section includes a screenshot of the browser prompt where users fill in necessary information during the installation process. The image shows the filled login form for account creation in Sentry, highlighting the step where users navigate to select their project. This screenshot depicts a situation where the Sentry CLI wizard is stuck on waiting for wizard to connect, suggesting a possible issue due to the need for email confirmation. The section illustrates email confirmation after account verification, indicating progress after resolving initial connection issues. With the email confirmed, the user can now access their Sentry project dashboard. However, it is noted that no files are created due to the need for browser session confirmation, suggesting that attention must be paid to ensure successful file generation. This section covers troubleshooting for the Sentry installation. If the automated setup fails, users can proceed manually by utilizing an auth token to bypass the browser authentication step. To generate an auth token, users must log into Sentry, access settings, and follow the steps for creating a new organization token. This token is crucial for manual installations. The section presents a screenshot of the Create New Token option in the Sentry dashboard, guiding users through the token generation process. This image captures the token creation form, where users enter permissions necessary for accessing their organization. After creating the token, this confirmation image assures users that they successfully generated a Sentry organization token required for subsequent setups. Users can run the Sentry wizard using their auth token to bypass the automated wizard's browser dependency. The specific command structure is illustrated here. Upon successful installation, Sentry stores configuration files essential to its operation. These files include client and server initialization scripts critical for effective error monitoring and handling. For deployments using CI/CD pipelines, it's essential to configure CI/CD secrets, including the Sentry auth token, organization slug, and project slug, which facilitate error tracking across deployment environments. Testing installation involves verifying if Sentry captures both client-side and server-side errors to ensure full error tracking functionality. To start the development server for testing Sentry, the command pnpm dev is required, indicating a successful setup should allow error testing. Users are instructed to navigate to a built-in test page to check if Sentry is configured properly by accessing a specific URL to trigger errors. This step guides users to induce test errors through various methods, ensuring that both server-side and client-side errors are captured and logged by Sentry for monitoring. Users are directed to visit their Sentry dashboard to check for new error events after triggering test errors, confirming that the integration is functioning. It's essential to check the email account linked with Sentry to confirm receipt of alerts for the triggered errors, ensuring that the monitoring setup is operational. When reviewing alerts, users should look for new issues captured in the dashboard and ensure they received corresponding email notifications regarding the errors, confirming a successful setup. This section addresses how to effectively run the project demo locally and how to configure Sentry for production deployment. Users are instructed to run the demo in development mode to see Sentry in action. Clicking designated buttons throws errors that should trigger email alerts, further validating the setup. To optimize free tier consumption, Sentry should be configured to run only in production. The necessary code adjustments are outlined to prevent unnecessary error tracking during local testing. This section addresses potential issues encountered during configuration and error tracking, providing solutions to common queries and unexpected behaviors. The confusion between age and last seen explains that while the error may seem recent, it may not trigger an alert due to Sentry's rules, offering solutions to notify every occurrence. This section provides troubleshooting steps if Sentry is capturing errors but not sending alert emails, including checks for alert rules and environment settings. This section outlines the technologies utilized in the project, organized by their system layers, emphasizing the Sentry integration. The core stack is primarily composed of Next.js and the post-to-video micro-SaaS, indicating the platform used for the application. This section discusses the infrastructure and deployment technologies, including DigitalOcean, NGINX, and PM2, showcasing the back-end environment supporting the SaaS. Monitoring and observability are covered with a focus on Sentry's real-time error tracking alongside other logging tools like Winston and Uptime Robot for external monitoring. This section details the design and architecture decisions made while utilizing Sentry for production error monitoring, emphasizing the decision-making process. The constraints highlight key considerations such as micro-SaaS scalability and cost-effectiveness when selecting monitoring solutions, ensuring Sentry meets these criteria. Various alerting options were evaluated against pros and cons, ultimately rejecting several in favor of Sentry for its effective error grouping and free tier limitations acceptable for micro-SaaS. The section explains the operational mechanics of how Sentry captures errors, enriches them with context, and transmits them for monitoring, detailing the flow from error capture to user notification. An error monitoring strategy is presented that integrates multiple layers of monitoring tools, with Sentry being the primary for alerting, ensuring comprehensive coverage across application and server levels. This section outlines the code structure of the application. It notes that the demo focuses primarily on error capture and alerting, simplifying the typical Sentry installation. The Sentry API is utilized for explicit error tracking, not only capturing crashes, but also tracking errors within business logic, ensuring a thorough overview of application states. This code snippet demonstrates the server-side API endpoint structure that showcases how Sentry automatically captures server crashes using a custom error class for reporting. The client-side code is highlighted here, demonstrating how Sentry can catch unhandled exceptions triggered by user interaction, showcasing real-time error reporting on the front end. Here, manual error reporting is illustrated, demonstrating how developers can explicitly report issues in the application using Sentry.CaptureException, enhancing observability. This section provides a visual walkthrough of the demo, illustrating the process from error triggering to receiving alerts via Sentry, facilitating user understanding of the monitoring capabilities. Screenshots from the demo highlight the main page of Post-to-Video, where test buttons are present, enabling users to directly interact and trigger error alerts. This image presents the Sentry interface after clicking the Throw Unhandled exception, showing alert notifications resulting from the triggered errors. Here, a listing of Sentry alerts is showcased, categorizing different types of errors that occurred, visually demonstrating the monitoring capabilities post-trigger. A screenshot highlights a specific case where an error is recorded, but due to alert rules in Sentry, no new alert is triggered, illustrating nuances in error reporting. This section provides reference links, specifically directing users to Sentry's documentation for additional guidance on using its integration with Next.js.